So, good afternoon. My name is Olena Surinovich from Lutsk National Technical University. Let me introduce our research. It's OpenStreetMap integration into the system of people safety and protection in emergencies. The tendency of increasing natural disaster and military conflicts through the world during the last 10 years leads to the death of a large number of people and material losses. Almost 9 years of military conflicts on the territory of Ukraine have caused significant damage to infrastructure, system, and services in the affected area. Lack of full uh, Lack of full access to transport, poor infrastructure, and communication in some regions led to large um, number of victims during air attack on Ukraine. So, according to a report by the Kiev School of Economics, it was made in February 22. The total amount of damaged cost of to Ukraine infrastructure due to full-scale Russian invasions is near $54 million. Current losses in such areas as infrastructure, education, emergency transport, trade, and health care continue to grow. So, in 2023, a series of powerful earthquakes were confirmed in Turkey and Syria. The total number of deaths in March in Turkey was 40,000 people, and the total number of victims in Turkey and Syria together exceeded 5,000 people, and it was maybe the worst situation in the world in this time. The purpose of protecting people and providing them with timely assistance in emergency situation involves the identification of dangerous and high-risk zones. It is a continuous process, and that requires the integration of data from various sources and expert options. So, this information is essential for developing effective emergency response plans, evacuation strategies, and determining measures for the actions of rescue and volunteers during emergencies. The main common parameters affecting the number of casualties in emergency situation in peacetime or in wartime are identified. So, high population density can lead to higher casualties and more difficult evacuation during emergency. One. Then the second, assessment of availability and adequacy of evacuation routes in designed areas. And so limited access can impede response and evacuation. Then the presence of vulnerable section of the population who cannot cope with this emergency situation on their own. So areas where access to medical care, emergency services, and resources may be limited, increasing risk to residents. Then reliability of communication infrastructure in these areas to facilitate coordination and response. Availability and operation efficiency of the surveillance and monitoring system to detect unusual actions or signs of potential emergency situation. So, uh, publicly available ways to quickly identify dangerous and high risk areas during emergencies. We include on our slides. It's mapping of GS, data, crowdsourcing, mobile apps and websites, networks and local communities, social media platforms, emergency notification systems. Um, 1 second. Okay. Um, Obtaining accurate and update to causality information during emergency situation is critical for both volunteers and professional resource services. This information helps to prioritize rescue operation, allocate resources, and provide assistance effectively. The most effective way of transmitting information about the number of location of people is modern IT technologies and navigation tools. So modern mobile devices, which are in almost everyone's pocket, make it possible to process a large amount of information and use it correctly and quickly. Special attention should be paid to geodata and geoservices during emergency situations. Today, from the point of view of the average users, Google Maps has become one of the most popular tools for navigation and exploring the world. Maps are used by millions of people every day to find, for example, direction, places, view some photos, and explore new remote locations. But thanks to the developing of the OpenStreetData Map project, researchers have a source of data, access to which is open and free. Yes, in addition, they themselves have the opportunity to edit this map, which thousands of volunteers do now. And applications are created based on this data that are used both for for navigation and research, including cities. Our research is based on the possibility of integration OpenStreetMap into existing emergency protection system. So the purpose of our study is developing some applications that allow them civilian population to get to shelters faster thanks to the use of data from the OpenStreetMap, then receive alarm notification to provide geodata of one's location from employees of resort rescue structure, and use handbooks on explosive objects and information on provided first aid, for example, and also find ways to integrate send notification about the discovery of suspicious objects. The tasks of our research are to find ways to integrate modern IT technologies and geospatial data into the system of security and protection of people from the negative impact of emergency situation based on information from open and publicity available source. So according to the identify my main parameters affecting the number of casualties in emergency situation, in peacetime and wartime are population, density, and number. Accordingly, it's necessary to carry out of a population account in order for rescue services and volunteers to obtain the most reliable information about number of residents of a house that could have been hit by a rocket or collapsed as a result of, for example, an earthquake. It was found that it is most impossible to obtain such calculation with absolute accuracy, since this process is affected by a huge number of factors that can be taken into account using open data. So, among them are the possibilities that no one lives in the house and apartment, or housing is used only for short-term rental, or this first floor of the building is partially used for commercial activities, for example, or individual apartments may not be used for the intended purpose. More than one family may live at home, and so on. In addition, it is necessary to take into account the fact that the accuracy and relevance of OpenStreetMap data is not always present in the areas described for analysis. Among the possible problems with them can be absence of applied residential buildings, incorrect tagging, for example, of buildings, then incomplete tagging of apartment buildings, and so on. The next information that needs to be outlined about the generated algorithm is the types of buildings to which it will be applied. It was decided to apply it to residential buildings of three types in our research. So you can see some formulas on our slide, but it will be a house. It consists of only one family lives. Then it can be a semi-detached house in which two family live, and it can be a multi-apartment building in which allows a large number of residents to live. At the end, regardless of the risk regarding to the accuracy of the calculation, the determination of approximate values was performed in the course of the research. For this work was carried out on a formation of the algorithms according to which the calculation will be carried out. In In the course of this research, in addition to using data available in OpenStreetMap, they were also introduced, updated, and clarified. So the majority of them concerns the central part of the city of Lutsk. We made our research in our city in some territory. So this slide shows what we do. The information and establishments was checked whether they still exist, their work hours, contacts, and new ones were added too. The addressing of buildings was specified according to the area and geospatial portal of the Lutsk City Council. The information on the presence of entrance in multi-apartment residential buildings and the number of apartments in them was clarified too. The information on the use of land areas located with the Lutsk urban community, it can be some industrial buildings in grass, trees, and so on. Forms of buildings were specified. The information on city streets lighting was added too. Sidewalks, paths, crossing over existing highways, and so on. And the information with shelters and points of invisibility was added to it. Maybe it was them important because we are some changing not only Lutsk but in other cities. So an example of such actions is the detailing of the area located in the area of Shevchenko's and Kovelska streets. It shows a figure 7 and figure 8. On this slide you can see before using open street map, and after using OpenStreetMap with our changes. Then a SWOT analysis was conducted to assess the possibility of integration OpenStreetMap into existing emergency protection system. But further stages of this research were devoted to the direct development of a software tools that could perform some analysis of existing OpenStreetMap content. Thanks to the function of analyzing the existing content of the corresponding geological in OpenStreetMap, ordinary residents of the city will also have the opportunity to use it. This will make it possible to use it in two possible situations. Let's consider each of them separately. For example, when an air alert signal is used, the user will be able to use the function of determining the nearest shelter with the fastest road to it. Unlike Google Maps, infrastructure and road data from OpenStreetMap will be displayed in more details, showing update and more accurate information around the user's location. The development application will allows the civilian population to get to shelters faster thanks to the use of data from OpenStreetMap. Then they can receive alarm notification. They can to provide geodata of one's location for employees of rescue structures, use handbooks on explosive objects and information on provided first aid, and also send notification about this discovery of suspicious objects. Um, OpenStreet integration into the emergency response system will provide responders, authorities, and communities with the geospatial tools and information they need to mitigate to the negative impacts of emergencies and protect life and infrastructure. After launching, the application and following results are expected. So, improved situation awareness, effective source allocation, improved evacuation planning. For example, OpenStreetMap's road network and traffic data help to design effective evacuation routes, assembly points, and traffic management. This helps to ensure the safe and orderly evacuation of people from dangerous areas. Then, accurate damage assessment, quick search and resource, effective communication. For example, OpenStreetMaps can be shared with the public, helping to raise awareness of emergency procedures, safe zones, and evacuation routes. This enables people to make informed decisions during cities. Then community involvement, then real-time monitoring. For example, OpenStreetMap integration allows for real-time monitoring of changes in infrastructure, population movements, and hazard patterns. This helps authorities remain proactive and responsive to changing situation. Then logistics, supplies, chain optimization, modeling and training, integrity cooperation, data driving decision making. So our research consists of analyze OpenStreetMap, its function, and we want to make some advice that will continue some tool, some not tools, some functions, such as functions that helps in future for all people in different cities in Ukraine. Maybe in future not in Ukraine, but maybe in a country where is some, for example, earthquakes can be, and so on. Thank you for attention. Please.
And thank you, Elena. Thank you, Elena, for your presentation. Maybe someone has one question because we have no time for a lot of questions, please.
Maybe I can ask a question.
Please.
Dear Elena, can you tell me how you take into account the probability of wrong recognition of the event?
Can you repeat the last?
How your system takes into account the probability of wrong recognition of the event?
We proposed, if, for example, we heard some air alarm, for example, yes, if the users must push a red button on her device, and the system can understand where these people are, and this signal transfer on, for example, police or medicine or another services, and for example, if a rocket destroyed this, for example, destroyed this building, these services can know how many people were in this house in this time.
Okay, thank you. But you need to take into account that not all users are so accurate as you're thinking about them. Thank you.
Okay, thank you. And thank you, Elena. Thank you, Vyacheslav, for the questions.